Red Bull's new 2026 engine is terrifying the entire Formula One grid, and they haven't even fired it up on track yet. Insider reports claim it's already outperforming projections by over 10% on the dyno, and that's without full race calibration. What's shocking isn't just the power, it's the way Red Bull and Ford have fused electric and combustion systems into one brutal, seamless unit. Subscribe now, because if this engine is as fast as they say, Red Bull might have just built the next era of F1 domination before anyone else showed up. Red Bull's 2026 power unit is not just causing intrigue, it's sparking full-scale anxiety inside rival engineering departments. As the new hybrid era approaches, teams are still navigating how to balance combustion efficiency with electric deployment. But while most constructors are caught in that learning curve, Red Bull Powertrains with Ford as their technology partner appears to have leapt ahead, unlocking performance targets that were not expected to be hit until well after the first test. Behind closed doors, engine dyno data is doing the rounds. The numbers coming out of Milton Keynes have raised eyebrows and pulses. According to insiders close to the FIA's technical monitoring group, Red Bull's prototype unit is showing extraordinary energy recovery rates under simulated race conditions. These are not speculative figures. These are raw outputs measured under full stress cycles, and the early word is this: Red Bull's system isn't just efficient, it's controllable across a wider rev band than any current hybrid unit. The most unsettling part for rival teams? It's the integration. Red Bull hasn't treated the power unit as a separate component. It's been built into the car's structural logic from the start. Ford engineers have worked in tandem with Red Bull aerodynamicists, packaging the unit so tightly that the entire rear of the chassis has been reshaped. That allows for cleaner airflow, reduced cooling drag, and sharper rear-end predictability. This isn't just about horsepower, it's about harmony. A machine that breathes in one piece. The fear inside technical circles is that Red Bull may have solved one of the hardest challenges of the 2026 regulations: the smooth delivery of hybrid torque during transient phases. Early versions of other power units have reportedly struggled to blend internal combustion with electrical support under throttle change. Red Bull's powertrain, however, is said to use a highly reactive control algorithm that responds in milliseconds. The result? Zero torque lag, and no dead zones on corner exit, the exact areas where lap time is won or lost. Another area that has turned heads is Red Bull's ability to sustain peak power without excess cooling. Thanks to Ford's investment in next-generation inverter and battery thermal management, the unit can reportedly operate near optimal output for extended periods without hitting thermal degradation thresholds. This has implications not just for raw pace, but for tire management and strategy. If the car can push longer without cooling dips, it can force other teams into defensive tactics earlier than expected. The combination of smart energy storage, fast-switching inverters, and reduced component weight has created a scenario that is as alarming as it is impressive. Rival teams aren't just worried about the launch spec. They're worried about how quickly Red Bull can develop it once real racing begins. If this engine is already performing at a competitive level in simulations, the in-season gains could become unmanageable, especially if other manufacturers are still troubleshooting software calibration or thermal mapping. What we're seeing here is not hype, it's trajectory. Red Bull didn't just build an engine. They built an adaptable energy platform that anticipates how the sport will evolve under new regulations. That kind of forward thinking, paired with Ford's rapid development tools and Red Bull's aerodynamic expertise, is why teams like Mercedes and Ferrari are watching this situation very closely. The monster has been built and it may already be awake. What's quietly setting Red Bull's 2026 engine apart isn't just its power, it's the unseen architecture behind how that power is delivered. One of the most confidential advancements lies in the modular hybrid energy module, developed with Ford's EV division. Unlike conventional layouts that prioritize packaging first and power flow second, this new system has been designed from the ground up as a performance-first solution. Each section of the battery stack operates independently under software direction, giving the system flexibility to shift energy delivery based on circuit characteristics: corner-heavy like Hungary, or power-hungry like Monza. Inside the MG UK, Red Bull engineers have reportedly implemented a variable response mode that can shift electric torque response time mid-lap. It's not reactive in a traditional sense, it's preemptive. The system uses predictive throttle mapping, GPS, gradient data, and tire temperature deltas to adjust deployment strategy before the driver even exits the turn. This level of foresight in energy application isn't just about saving power, it's about ensuring that the car's acceleration curve never surprises the rear tires. That means more consistent grip, lap after lap. Another closely guarded asset is the inverter efficiency curve, which appears to outperform expectations by a significant margin. Most F1 inverters are limited by the speed at which they switch current between battery and motor. Ford's new silicon carbide technology has increased switching frequency by over 30% compared to legacy systems. This allows for sharper torque modulation and smoother transitions between ICE and electric modes. Crucially, it reduces heat output, meaning less thermal load, more compact radiators, and additional freedom for aerodynamic reshaping at the rear end. One area of development that few have discussed is the passive vibration damping system that supports energy regeneration during braking. Typically, under heavy deceleration, F1 cars struggle with high-frequency vibrations that degrade regenerative braking efficiency. Red Bull's design reportedly uses micro-tuned mass dampers integrated into the powertrain casing to smooth out these oscillations. The result? A cleaner flow of harvested energy, less rear instability under trail braking, and a power unit that doesn't suffer the typical balance shift during braking zones. There's also been movement in software learning loops, specifically how the car adapts throughout a race. Ford's real-time data telemetry tools have been imported from their electric vehicle R&D and implemented into the Red Bull test environment. This allows the engine to learn from each lap and subtly adjust its hybrid timing, energy split, and thermal sealing tolerance. It's not artificial intelligence, but it's dangerously close. This edge is invisible from outside the car, but could be decisive over race distance. Perhaps the most underestimated element is the structural integration of the power unit into the rear suspension platform. Red Bull has shifted the mounting points and internal stiffness profiles to ensure the engine doesn't just drive the car, it supports it. This has given their engineers more freedom in controlling vertical loads through the diffuser and allows for a more predictable aerodynamic seal under high G-forces. In a year where floor performance and energy recovery will need to coexist perfectly, this tight physical integration could give Red Bull a mechanical grip advantage when others struggle to balance forces. Finally, what has rival teams watching closely is Red Bull's timeline. Most manufacturers are aiming for late winter full integration tests. Red Bull, however, has reportedly begun closed-loop calibration trials using a complete rear-end mule with the power unit, suspension, and cooling systems running in harmony. That level of readiness in late 2025 suggests they're not just building for 2026, they're targeting domination from the very first race. And in Formula One, being ready before the others show up? That's where championships begin. At the core of Red Bull's 2026 engine program lies a concept that's redefining how Formula One understands power units. Integration is architecture, not just packaging. This is not an engine simply fitted into a chassis. It's a drivetrain that has been co-developed with the car from its first line of CAD code. Every contour of the rear bodywork, every duct, every cooling loop, it has all been influenced by the physical demands of this power unit. And what's most impressive is that this harmony was not a compromise. It was the plan from day one. The Red Bull-Ford partnership took an unconventional approach by flattening the development hierarchy. Instead of siloing engine design from chassis and aerodynamics, they created a shared design language across disciplines. This allowed them to reduce inefficiencies that usually emerge when components are developed in isolation. For example, the MG UK housing was designed not just to withstand torque, but to channel air toward thermal hotspots. The intercoolers are placed to enhance weight distribution and diffuser performance. These are not afterthoughts. They are integrated design strategies executed with surgical intent. Mechanically, one of the most talked about aspects within engineering circles is the vibration neutrality of the internal combustion unit. While other manufacturers have battled instability when transitioning between electric and ICE power, Red Bull's engine reportedly remains neutral across those switchover zones. This eliminates chassis resonance, prevents unpredictable rear-end behavior, and improves driver confidence when traction is at its most fragile, particularly on corner exit under variable torque delivery. That smoothness extends to what engineers are calling torque layering. In this configuration, the engine doesn't just blend ICE and electric power, it overlays them with variable emphasis depending on wheel slip, throttle progression, and even track temperature. The car knows how to bias the energy where it matters most. For example, on high degradation circuits, it leans more on electric torque to preserve rear tires. On low downforce tracks, it ramps up combustion power to maximize straight-line performance. That level of adaptability is something no other team has publicly demonstrated. Another massive leap has been achieved in thermal control under race simulation. Ford's energy management system includes dynamic cell balancing, allowing the battery to reroute current in real time to minimize local overheating. During long runs, this has the dual effect of maintaining peak power longer and reducing the thermal stress on sensitive electronics. This is not just a performance benefit, it's a reliability asset. In a regulation era where engine penalties still matter, finishing every race is half the title fight. Red Bull's engineers have also found a way to maintain structural rigidity without sacrificing flexibility in suspension tuning. By reinforcing the rear bulkhead around the engine mount with a lightweight composite exoshell, they've eliminated microflex while allowing the suspension geometry to operate independently of engine load. That means better control over tire contact patches, improved rake stability, and more precise aerodynamic consistency through long corners, all of which contribute to race day pace, not just qualifying bursts. The result of all this engineering? A platform that is not just fast, it's self-coherent. Every subsystem is supporting another. The engine helps the aero. The aero helps the cooling. The cooling helps the battery. And the battery, in turn, unlocks torque when needed most. In a season where margins will be microscopic, this level of interdependence may be what separates the contenders from the champions. And Red Bull is no longer experimenting. They're executing, and everyone else now has to play catch-up against a machine that was built to evolve from the very first kilometer.